Okay, pause, copy, and try these exercises. Pause, copy, try. Okay, this determinant business is not too hard, but it's important to iron out all the wrinkles as soon as possible. So try these and let me know how they go. So I gave you the answers over here and ask me during class if you have trouble. Okay, scroll up here. All right, pause and copy all this. Pause and copy. Okay, Theorem 4 we've already mentioned. Okay, the determinant tells us whether A inverse exists or not. In the book, they give proofs here. Okay, my feeling about proofs are that they are not a good use of class time at the stage up level, at least. But if you're curious, you should have a look there in the textbook. You won't be asked to reproduce anything from these proofs. Okay, now I want you to try the exercise. So pause and try the exercise. And we'll go through it. Let's see. So part A, what do I get? What is A times B? A times B, 24 plus 1 is 25. 18 plus 2 is 20. Hope I don't make a mistake. 12 plus 2 is 14. 9 plus 4 is 13. So what do I get here? Oh boy. What is 25 times 13? 13 quarters. I have 13 quarters in my pocket. How much money do I have? What is that? $3.25 minus 280. Probably made a mistake here, but such is life. Well, let's do part B before we start jumping to conclusions about my math skills. 12 minus 3 and 8 minus 3, which is 9 times 5 is 45. Good. That is a good sign. C, A plus B. 10, 4, 4, 4. 10, 4, 4, 4. Okay. 40 minus 16 is 24. And then D, I get, what do I get? 9 minus 5, which is 4. All right. Okay. So what does this hint at? Well, in general, these two things are not the same. They could be, in certain specific situations, but overall, that's just not a thing. But this suggests that there is something happening there. And yes, there is something happening there. And this is theorem something, something, something 6. Okay, if you do the determinant of the product, that is indeed going to be the product of the determinants. Again, you can see 3.2 if you want to check out a proof of this thing. Let's do an example to illustrate. Okay, here we're going to given the determinant of A is -2, determinant of B is 3. Okay, so yeah, I know the notation is not great here. The absolute value would make you think it's always positive, but it's not the case. Determinants can be positive, 0, or negative. Back to my question. So I'm going to find something. A squared BA. B. What is the determinant of A inverse? And what is the determinant of 2B? 2B, where we give you the additional and necessary information that B is 3 by 3. Okay, let's ponder this. If you're feeling confident, you can try this, but I'm going to go ahead and do it. A. Okay, so here we have the determinant of the product is the product of the individual determinants. Okay, so I mean, the theorem only gives you 2 matrices, but if you have a product of whatever 26 matrices, it still works. So this is A cubed determinant of A cubed dot determinant of B. So this is -2 cubed times 3, which is -24. Right. Okay, part B is not so easy. We first notice that A times A inverse is the identity matrix. All right. That's what the inverse means, right? Now we apply the determinant to both sides. And we use our theorem to isolate, or to help us isolate what we want. Now, what is the determinant of I? I is a diagonal matrix, so that's right. Determinant of I is just 1 times 1 times 1. It's just a bunch of ones multiplied. Okay, we saw this in 3.1. When you have an upper triangular or lower triangular matrix, the determinant is just the product of the diagonal matrix elements. Yeah. Okay, so we just get 1 here. Equals 1. So A inverse is equal to 1 over, the determinant of A inverse is equal to 1 over the determinant of A. So that's actually a formula that is worth memorizing. Let's put a rectangle around that. So in our case, this is 1 over minus 2. And whatever, you can write that a bit nicer. That was right. A was, yeah, okay. C. Two B. 2 times B. So we'll do a little trick here. We'll say B is the same as I times B, right? So we'll get 2I B. And now I can use my formula to get 2I here dot 2B. Now, what does 2I look like? 2I looks like, well, it's just this thing with 2's. Oops. There's only 3 of them. No. No. So that's 2I, right? So the determinant of 2I is 2 cubed. Shoot. I got a typo here. This 2 is not supposed to be there. Should never talk and write at the same time. Okay, that's better. Now, what was the determinant of B? I have forgotten looking. 3. Come on. 3. And then I get plus 24. So this gives us a formula, this idea. If you have a number times a matrix, you can move that number out. But you have to put, so the number 2 came out, but then I had this exponent, which is the number of rows or columns. So here K is a real number, and B is n by n. Okay, one more example. So of a different flavor. Okay, given A, B, C, D is equal to 7, find a find these two determinants. Okay, so what we're going to do is we are going to find, we're going to try to use this information here. So I'm going to do row operations here until I get here. And that will be my approach. So how can I get from here to here? What row operations? Well, what I'm going to do is I'm going to notice that I want this C to be down here, right? So I will transpose the matrix. Okay, transposing does not change the determinant. So this was, what was this? Theorem 5. And then I want the minus 2C and the minus 2D to go away. And to do that, I go row 1 plus 2, row 2. I do a replacement. And that does not change the determinant either. And then, okay, I'm back to my given information, which is, so this is just 7 as well. Part B. A, B, 3, C, 3, D. Okay, so we've seen this before. The 3 can just move out front. So we get 3 times 7, giving us 21. Okay, let's look at part A there. If you think about it, I did a transpose to get this, and then I did a row operation, right? But I could have kind of done that in a different order. I could have instead have done a column operation first. I could have done column 1 plus 2, column 2, right? And then a transpose afterwards. And then I would end up in the same place. Well, the question is, well, can I always do that? Can I do column operations? Well, if you think about it, because the transpose does not change the determinant, and we have some ability to do row operations, okay, together, that means we can do column operations. So I'll write it like this: Theorem 3 plus Theorem 5 says that we can do column operations. That follow the same rules. As those for row operations. as for row operations. Okay, this is rarely, I don't think this is ever necessary, but it's something you can do if you want to. Okay, so you can do column replacements, column interchanges. And as long as you basically take Theorem 3, replace the word row with column, and as long as you follow those rules, it's still valid.